Good morning, one and all. Today I am going to present in this session what is the Lagrange's method. The working rule in the Lagrange's method involves in the first step, given a PDE in the form P into capital P into small p plus capital Q into small q is equals to R, where this small p and q represents respectively dou z by dou x and dou z by dou y. We form an equation of the form dx by capital P plus dx by the capital Q is equal to dz by capital R, which is known as the auxiliary equation, where this capital P, Q and R will be functions of x, y, z. Second step, we consider suitable pairs which can be put in the forms like f of x into dx is g of y into dy and g of y into dy is equal to h of z into dz, or f of x into dx is equal to h of z into dz. By integration, we can get the relation x comma y or y comma z or z comma x as the case may be. We have a property in the ratio and the proportion that a ratio a1 by b1 is equal to a2 by b2 is equal to a3 by b3 is also equal to k1 a1 plus k2 a2 plus k3 a3 whole divided by k1 b1 plus k2 b2 plus k3 b3. With reference to the auxiliary equation, we try to find the multipliers k1, k2, k3, k1 dash, k2 dash, k3 dash such that the denominator will become 0. So that dx by p is equal to dy by q is equal to dz by r is equal to, this is equated, that is k1 dx plus k2 dy plus k3 dz divided by k1p plus k2q plus k3r, which can be also equals to k1 dash dx plus k2 dash dy plus k3 dash dz is equal to k1 dash p plus k2 dash q plus k3 dash r. The next step is integrating the two new expression. We obtain the two relations connecting x, y and z. The next step, suppose u of xyz is equal to c1 and v of xyz is equal to c2 are the two relations so obtained, then phi of uv is equal to 0 constitute a general solution of the PDE. PP plus QQ is equal to R. These are the steps involved in order to find by Lagrange method. Let's see the problems now. Solve x dou z by dou x plus y dou z by dou y is equal to z. The given equation is of the form PP plus QQ is R and the auxiliary equations are given by dx by x is equal to dy by y is equal to dz by z. Now consider dx by x is equal to dy by dy, that is the first term, and then the second terms are considered. Now the variables are already separated. Dx is with x and dy is with y, which can be directly integrated. So on integration we get log x is equal to log y and integration constant which should be similar to these two terms, that is log c1. So log x minus log y is equal to log c1, we get it, that can be written as log of x by y is equal to log of c1, that is x by y is c1. Next, one more term is required, that is why we consider the second and the third one, that is dy by y is equal to dz by z, and proceeding on the same lines as that of the previous one, we get log y is equal to log z plus c2. So log of y minus log of z is equals to log of c2, or y by z is equals to c2. So same way we proceed, we get y by z is equals to c2. Hence, the general solution of the PDA is given by phi of x by y into comma y by z is equals to 0. This is the solution. Third equation. Y minus z into p plus z minus x into q is equal to x minus y. The given equation is of the form pp plus qq is equal to r, whose auxiliary equation is dx by y minus z is equal to dy by z minus x, which is equal to dz by x minus y. In this case, even though we have equated dx and dy or dy and dz, that is the first and second or the second and third term, we will not be able to segregate the variables in such a way that y terms will be clubbed with y and the x terms with x. That is not possible. So we use the next option, that is by choosing the suitable multipliers. So we can choose the multipliers as 1, 1, 1, so that when we add the denominators, it will be 0. Other one is x, y and then z. Then also by adding, the denominator will be 0. That is, first one is by using the multipliers 1, 1, 1 in each ratio. It is dx plus dy plus dz divided by y minus z plus z minus x plus x minus y, which totally gives 0. That is, dx plus dy plus dz is equals to 0, which on integration we get x plus y plus z is equals to c1. Another set of multipliers we need to get, that is x, y, z in each ratio is equal to x dx plus y dy plus z dz is equals to x dx plus y dy plus z dz whole divided by 0, because you can observe in the denominator xy minus xz plus yz minus xy plus xz minus yz. All the terms get cancelled. We get this one, which on integration we get x square by 2 plus y square by 2 plus z square by 2 is equals to c2, and which on cross multiplication we get x square plus y square plus z square is equals to 2c2. Thus, the general solution of the PDE is given by x plus y plus z, comma x square plus y square plus z square is equal to 0. This is the required solution. Thank you.